If you need to pass GED Math so that you can move ahead to bigger and better things in life like college or a better job, joining the military, whatever your goal happens to be, then you're going to want to know how to beat GED geometry questions. Now, on GED Math, if you can get more geometry questions right, it's going to help your score. And I really hoped I could get this done in just one video, but unfortunately my laptop's out of space, so that's why I have to break it up into two parts, and I'm going to put a link to part two whenever it's done down below in the description. Now, if you really understand everything that I cover in part 1 and part 2, these might be the only two videos you need to watch to prepare for GED geometry. That being said, I can't make any guarantees, and it's totally up to you to decide for yourself if you want to do more geometry practice after you watch these two videos, but I've tried really hard to simplify everything and get it all into just these two videos, at least enough to help you get the majority of GED geometry questions right. And I think if you understand everything, I think you'll have a good shot at doing that. So thank you so much for being here. I really hope this is helpful, and I'm going to let you get started now. So let's talk about how to find the area and perimeter of squares. So I have on the screen here, this is a square, and I have two formulas, and these formulas I got right off the GED formula sheet that they'll give you on the test when you take the test. So you don't have to memorize these, but you will have to know how to use them. So the formula for the area of a square is side squared. So another way to think about this is side times side. All right, but on the formula sheet, they're going to give you side squared. Now, for perimeter, all right, I have perimeter equals 4s. This is the formula, again, that comes right off of the GED math formula sheet. See right here, they have perimeter equals 4s. So that's what I have written here. And for this example, let's say that the length of a side is 5. So for a square, all sides are going to be the same length here. So every single side here is length 5. And we're not going to worry about the inches. This could be 5 meters, 5 centimeters. We don't really care about the units right now since we're just practicing. So let's have you try, if you'd like to calculate both the area and the perimeter for the square above if s equals 5. So if you'd like to, you can pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so let's start with the area here. So to find the area, what we want to do is we're going to just do 5 squared. Okay, so in your calculator, you can do it that way. 5 squared is also the same as just doing 5 times 5. So if you want to do 5 squared or if you want to do 5 times 5, either way, you'll get the same answer. But the area of this square is 25. Now for the perimeter, all we have to do is we're going to do 4 times 5. And 4 times 5 is 20. So the answers here are 25 for the area and 20 for the perimeter. So here's another variation that they could ask you. So instead of asking you to calculate the area of a square on the test, they could also give you that area and ask you to find the length of one side of the square. So here's the next example. It says, if the area of the square is 64 square meters, what is the length of one side of the square? So this time we have to find what s equals given the area. So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So in this case, we're going to use that area formula again. So area of the square equals s squared. And this time we know that a equals 64. So I'm going to come up into this formula and I'm going to plug 64 into the formula for a. And all I mean by that is instead of writing a equals s squared, I'm going to now write 64 equals s squared, because we know that the area of the square in this example is 64. So I have 64s squared and I want to find s. So a really super common mistake in a scenario like this would be to think, well, to get s, what I have to do is square both sides. So if you did that, don't feel bad at all. Absolutely don't feel bad, because this is one of the most common mistakes I see with GED test takers. So I'm just pointing this out now so that you know if you get an example on the test that you don't want to do this if you get a scenario like this. What you want to do is you want to take the square root. So again, we have 64 equals s squared. We want to get just s. And the way to do this is we want to take the square root of both sides. So we take the square root of both sides. So the square root of 64 is 8, and we would see that 8 equals s in this example. So the correct answer for this example is 8. So let's switch gears and talk about the area and perimeter of rectangles. So The two formulas that show up on the GED math formula sheet are area equals length times width, and perimeter equals 2L plus 2W. Now here, this is our rectangle, and for this rectangle, we see that this side is called the width, and this side up here is called the length. Now, with a square, each side is the same length. Now, for a rectangle, this side up here, I can't even draw right on this. This side up here and this side down here are going to be equal in length. And this side over here and this side over here are going to also be equal in length. So, for example, what I mean is if the length of the rectangle is 3, so if this side up here is 3, this side down here also has to be 3. So if this side of the rectangle, if we know the width is, say, 2, for example, this side over here is also going to be 2. All right, so the sides across from each other are going to be the same length for a rectangle. So again, with a square, every side is equal for a rectangle. All right, this side is going to be equal to this side in length, and this side over here is going to be equal to this side over here in length. So hopefully that makes sense. Now, in this example here, we're told that if the length equals 8 meters and the width equals 2 meters, please calculate both the area and perimeter of the rectangle. So let me give you a chance now to pause the video, try this out, and whenever you're ready, just unpause the video and we'll talk about it. Okay, so for the area calculation here, we're just going to do 2 times 8, right? Because we're told that if the length equals 8 and the width equals 2 meters, so the formula for area is length times width. So area is going to equal 8 times 2 here, which is 16. So the area is 16 here. Now for the perimeter, all right, this is the formula that they tell you to use on the test. It's 2L plus 2W. But another way to do it is just add up all of the sides. So we know that the length equals 8. So this side up here, I know equals 8. And because I know that this side up here equals 8, I know that this side down here also equals 8. And since I'm told that the width equals 2, I know that this side right here equals 2. So therefore, I also know that this side over here is going to be 2. All right. So then what I can do is just go around and add them all up. So I can do 2 plus 8 plus 2 plus 8. So that's one way to do it. But if you want to just do it with the formula, what you would do is you would do perimeter equals 2 times L, and we know that L equals 8. Then we're going to do plus 2 times W, and we know that W equals 2. So if we do this, what we get is 20. So however you want to find the perimeter, the answer is going to be 20. So we have area equals 16, and we know that perimeter equals 20. So here's another variation of an area problem for the rectangle. So if the area of the rectangle is 77 square inches and the width is 7 inches, what is the length? So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, just unpause the video, and whether you get it right or wrong, we'll talk about it. Okay, so we're going to use this formula for area here, and we're told that the area is 77 square inches. So what I'm going to do is I'm going to take the 77, and I'm going to substitute it into the formula for A. Now we're also told that the width is 7 inches. So I'm going to come up into the formula with the 7, and I'm going to plug the 7 in for the W. Now let me show you what I mean by this. So I'm going to rewrite this formula, and instead of writing A, I'm going to write 77, because we know that the area of the rectangle is 77. Now, we don't know what L is, so I'm just going to put an L right here. This might look like an I, but let's just pretend this is an L. And the W is 7, so I'm going to put a 7 here for our W. So we've got, let me make this a capital L just so we can tell it's not a 1 or an I or something. So we've got 77 equals L times 7. And we want to get L. So what we want to do here is divide by 7 on both sides. And if I do that, what I see is that the 7's cancel out over here, leaving me with L. And on this side, 77 divided by 7 is 11. So the answer here is 11. So the length of the rectangle in this case would be 11. If the perimeter of a rectangle is 200 feet and the length is 75 feet, what is the width of the rectangle? So now's your chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So in this case, we're going to use this perimeter formula, and we're going to take the 200, and we're going to plug that into the formula in place of P. And since we know that the length is 75, we're going to take the 75 and plug it in here for L. So what we'd have then is 200 equals 2 times 200. And there's some kind of power tool that they're using outside of my apartment right now. I hope that's not coming into the audio. So I do apologize if you're hearing that in the audio right now. I'm sure it's distracting for you. It's kind of distracting for me as I just almost wrote the wrong thing here. So I do apologize for that. Unfortunately, I don't have a whole lot of time to record this week, so I'm just going to kind of have to roll with it unless it gets really bad. But anyway, I probably just disrupted your train of thought as you follow along here, because my train of thought is distracted. But anyway, we've got 200 equals 2 times 75 plus 2W. So 2 times 75 is going to be 150. So when I rewrite this, I would have 200 equals 150 plus 2W. And the name of the game here is to get this W by itself. So now what we want to do is we want to subtract the 150. All right, so if we subtract 150 on both sides, the 150s cancel off on the right-hand side of the equation, and on the left-hand side of the equation, what we're going to get is 50 equals 2W. So we're getting closer. So this 2W is 2 times W, and we want to do the opposite of times, which is division. So if we divide by 2 on both sides, we're going to see that the answer here is 25. So 25 equals W. So that's the correct answer here. So now let's talk about the area and perimeter of triangles. So the formulas that they give you on the sheet are A equals half B times H, and P equals side 1 plus side 2 plus side 3. And on screen, we see a triangle, and this side of the triangle is the height, and this side over here is the base. So the example question here on the screen is if the base of a triangle is 15 inches and the height is 20 inches, what is the area of the triangle in square inches? So let me give you a chance now to pause the video if you'd like to, try to figure this out, and whenever you're ready, we'll go over the answer. So to do this question, I'm just going to take this formula, and I know that the height is 15, I know that the base is 15. So I'm going to write A equals half times 15, and I know that the height is 20, so I'm going to use 20 here for the height. So I have half times 15 times 20. Now, you could just plug this all in your calculator and get the answer that way. That's perfectly fine. But what I'm going to do here is, since we've got a 20 and we've got a 2, all right, 20 divided by 2 is 10. So I can actually rewrite this as A equals 15 times 10. And 15 times 10 is 150. So the area equals 150. Like I said, you could probably just put this in your calculator and do it that way. You can always work these out by hand, whatever's easiest for you. But the answer here is 150. So here's another example. What is the perimeter of the triangle above? And I've labeled the length of each side here. So let me give you a chance if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so basically to get the perimeter here, all we're going to do is just add up the sides. So it doesn't really matter which order you do them in, but we're going to do 20 plus 16 plus 14. And again, it doesn't really matter if you do 14 plus 16 plus 20. The order doesn't matter here. We're just going to do side plus side plus side. So just add up all of the sides. And if we do this, the answer is 50. And if you ever get a triangle like this and you're trying to figure out which side is the height, well, the height actually comes right down the middle of the triangle like this. All right, so right here, this would be your height, this little line coming right down here in the middle of the triangle. And the base would just be 14. So just keep that in mind. So here's another example of an area question for triangles. So if the area of a triangle is 2,500 square meters and the base is 50 meters, what is the height in meters? So let me give you a chance now if you'd like to pause the video, try to figure this out. And if you get stuck, don't worry about it because we're just going to go over the answer. Okay, hopefully I had a chance to try this if you wanted to. Let's talk about it. So if the area is 2,500, so what I'm going to do is take that 2,500 and I'm going to plug it into the formula in place of the A. Now we know that the base is 50 meters, so I'm going to take this 50 and I'm going to plug it in here in place of the B. So let me rewrite this formula, and when I rewrite it, again, instead of writing A, the letter A, I'm going to write 2,500, and I'm going to do 2,500 is equal to half times the base, which we know is 50, so half times 50 times h, and we don't know what h is, so I'm just going to leave the letter h here. So what I can do now is do half times 50. Half times 50 is the same as 50 divided by 2, however you want to look at it. But if I do that, I can simplify this as 2,500 equals 25 times h. And so now what I want to do is divide by 25 on both sides here. So I divide by 25 on the right-hand side, I divide by 25 on the left-hand side, and the result is 100 equals h. So the correct answer here is 100.
Tommy, what's the difference between a triangle and a circle? You don't know? All right, good try.
So now let's talk about parallelograms. So the one on top here, the picture on top here that I have the arrow pointing to is a parallelogram. And down here is a picture of a square. Now you might say, why do you have a picture of a parallelogram and a picture of a rectangle? Or sorry, did I say this was a square? This is a rectangle. Anyway, all rectangles are parallelograms, but not all parallelograms are rectangles. You say, well, who cares? I don't know, just an interesting bit of trivia I threw out there. But anyway, they have some commonalities, right? So they're both four-sided plane figures. So they both have four sides. And what you should notice here with this parallelogram is that this side right here and this side down here are parallel. They're both parallel sides and they're the same length. Just like on a rectangle. Remember before I said that this side of the rectangle and this side of the rectangle are equal in length? It's the same with a parallelogram. Now also this side right here and this side right here, all right, these sides of the parallelogram are parallel with each other and they are both the same length. Same with a rectangle. So this side right here is equal to this side in length and they're also parallel to each other. So I'm just showing, the sides that are equal. So this side with the two slashes is equal to this side that has two slashes, and the side that has one slash is equal to the side with one slash. All right. So in that sense, the parallelogram is similar to the rectangle. All right. So again, on this parallelogram, this side is equal to this side, and this side over here with the two slashes is equal to the side with two slashes. That was kind of a mouthful to say, but anyway, hopefully you get the point here. Also, the internal angles of a parallelogram and the internal angles of rectangles all add up to be 360 degrees. And when we talk about four-sided plane figures, I think I'm going to put that later on in the video. I haven't decided yet. I'm just kind of recording right now, just trying to get as much recorded as I can, and then I'm going to go back and edit. And actually, recording this video, this is the kind of the fun part for me, and then going back and editing all of this footage together, that's kind of the more tedious part. But basically, in a parallelogram, this side is equal to this side. These angles, not sides, these angles are opposite each other, and they're equal. Now, this angle right here, that's opposite to this angle down here, these angles are opposite, and they're also equal. All right. Now, the difference is that in a rectangle, all right, all of the internal angles are 90 degrees. So every single internal angle in a rectangle is 90 degrees. And with a parallelogram, all right, the angles that are opposite from each other are equal. So again, this angle is equal in measure to this angle. This angle is equal in measure to this angle down here. And again, I'm going to make that four-sided plane figure section of this video. I'm probably going to put it after this section. So it should be later on in the video unless I change my mind and put it earlier in the video. I haven't made that decision yet. I'll do it when I'm editing, but whenever you see that four-sided plane figure part, we're going to talk about this more in depth. I'm just kind of trying to just put this idea out here just to kind of plant that seed now. So hopefully it'll make more sense when we see it later in the video. But the main thing that I want to talk about right now is how to get the area of a parallelogram. So the area of the parallelogram calculation is pretty straightforward. It's just the base times the height. And let me get these lines off the screen here. The height of a parallelogram, there's a couple different ways they could write it. So this line right here is the height, and they could just put the height, like a value for the height right here. They could also write it out here on the edge like we see here. They might also put like dotted lines right here for the height. But here we just see a solid line. But however you want to look at it, however they show you it, know that the base would be this line, either this line right here, or it could also be this line right here because they are the same length. And then the height would be either this line right here, or they might just put it out here like this. And so really all you're going to do to get the area is you're going to multiply base times height. So for the sake of time, I'm not going to show an example of this, but like I'll just show you how to do it. So if we knew that if the height was 4, for example, and the base was 9, you would just do 4 times 9. And so you might be wondering, what about the perimeter of a parallelogram? Do I have to do a calculation for the perimeter? And I don't think that you do, because on the math formula sheet, right, if we look at the formula sheet for the GED math section, there is no formula for the perimeter of a parallelogram listed. They definitely have the formula for the area of the parallelogram. So I would know how to do the area calculation. It's just the base times the height. But they have no formula listed for the perimeter. So I am going to assume that you don't have to find the perimeter of a parallelogram. But just to kind of cover our bases, let me just tell you how you would do that. So basically, the perimeter of a parallelogram, what you would do is you would just add up the length of all the sides. So you would take this side, and this side, and this side, and this side, and you'd add them up. So let's talk about trapezoids now. So the area of a trapezoid, we get that from the formula A equals half times H, parenthesis B1 plus B2 parenthesis. Now, what we have to see here is that there are two different bases. So this line right here, this is one of the bases. And this line down here, this is the other base. So trapezoids have two different bases, and you can tell which ones are the bases because they are straight lines. All right, so this is a straight line, and this is a straight line down here. These two flat lines, these are the bases. All right, so this line right here, this is a lateral line, and this is another lateral line right here. So see how these lines are diagonal like this? So, right, so that's how you know that they aren't the bases. So the height, which I'm going to write in right now, the height is found right here. One thing that I want you to see here is that the height and the bases are perpendicular. What that means is that if I take the base here and I just keep drawing a straight line, if I just extend the base out here and I take the line that shows the height and I just keep it going like this, we see that they make a cross. All right, same with this base down here. So if I just trace this base down here and I take the line that shows the height and I just keep going with it, we would see that the base and the height form a cross. All right, just like this, just a cross. And these lines aren't straight because my pen, maybe it's not the pen, maybe it's just me. But imagine this is a straight line coming down here. So a cross is the key example of perpendicular lines. So basically we see that we've got one line going left and right and one line going up and down, and they intersect at a 90-degree angle. And that's all this little box type thing is. It just tells us that we have a 90-degree angle. But you should know that the bases are perpendicular to the height. Okay, so to do this, what we want to do is just use the formula. So we know that the height is 30. So I'm going to come up here to this H, and I'm going to plug in 30. So we would have A equals half times 30 times B1 plus B2. And we're told here that base 1 is 20, and we're told here that base 2 is 25. Now you could flip-flop them. You could put 25 first and 20 second. It doesn't really matter here. So if you're ever not sure which one's base 1 and which one is base 2, it doesn't really matter. Like you could plug in 25 for base 1 and 20 for base 2 and you get the same answer, just as long as you correctly realize that one base has to go in here and the other base has to go in there. Anyway, you would do A equals half times 30 parentheses 20 plus 25. Now, you could just put this right in your calculator if you wanted to, or you could just kind of simplify it first. So you could do 30 divided by 2, which is 15, and 20 plus 25, which is 45. So you could also do 15 times 45, and the answer, if you do it that way, is 675. Now, if you just plug this into your calculator, half times 30, parentheses 20 plus 25, parentheses, you're also going to get 675. So the correct answer here is 675. Here's a different example that has to do with the area of a trapezoid. So let's say that this time you know that the area of the trapezoid is 250, the length of base 1 is 50, and the length of base 2 is 65. What is the height? Now, let's disregard units so we don't care about units, and I also don't care how you round it. This is just a practice example, so let me give you a chance now to pause the video, try to figure this out, take all the time you need, and if you get stuck, don't worry because we're just going to go over the answer. Okay, so in this case here, let's just write 250 in the formula for area. So I'm going to take 250 and I'm going to plug it into the formula for A. So we have 250 equals half times h, and we don't know what the height is, so I'm just going to put an h here for height. And we know that the length of base 1 is 50, and we know that the length of base 2 is 65. So I'm going to have 50 plus 65. And again, you could do 65 plus 50. Whether you do 50 plus 65 or 65 plus 50, either way, it's going to give you the same answer. So 50 plus 65 is 115. So I have 250. If I rewrite, 250 equals half times h, and then times 115, because 50 plus 65 is 115. So now what I'm going to do is I'm going to do 115 divided by 2. And now I'm going to rewrite again. So I have 250 equals 57.5 times h. So now, how do I get the h? Well, I'm going to divide by 57.5 on both sides. So if I do 57.5 divided by 57.5, these numbers will cancel out. But I also have to come over here to the 250, and I have to do 250 divided by 57.5. And if I do that, I'll get something like this, 4.348. And again, I don't really care how you round, as long as you got something close to this. Consider that you got the right answer here. So just one last thing to note here about trapezoids. If you had to calculate the perimeter, what you would do is do side plus side plus side plus side. You would just add up the length of the four sides, and that would give you the perimeter of the trapezoid. They don't have it listed on the formula sheet. I wouldn't stress out about it, but just know that that's how you would do it. You do side plus side plus side plus side. So we're not going to go over an example of that, but that's how you would do it if you had to. When it comes to talking about circles and what you should know about circles for GED math, basically understanding that the difference between the radius and the diameter is a great starting point. So the radius is the length of the line from a point on the circle to the circle's center, and the diameter is the length of the line that goes from one point on the circle to the center, and then to another point on the circle. And it's easy to hear these definitions and think, well, what in the world does that mean? So I think it'll make more sense when we go over the pictures down here. And basically the way I think of it is if you start at a point on the circle and you go all the way, you go halfway across the circle, that's the radius. If you start at a point on the circle and you go the full way across, that is the diameter. So again, the radius, you're going halfway across the circle. The diameter, you're going the full way. That's the easy way to remember it. And from that, we can see that the diameter is twice the radius. So if the radius is 6, the diameter is 12. So we can write some formulas now. So we can say that the radius is equal to half of the diameter. So let's say that I gave you 30 and I said, hey, the diameter of a circle is 30. What's the radius? Well, to get the radius, you would just cut it in half and the answer would be 15. All right. Now, what if you wanted to find the diameter? Well, we should know that the diameter is equal to twice the radius. So let's say that I told you that the radius of a circle was 10. If I said, hey, the radius is 10, how do you find the diameter? You would just double that. You just do 10 times 2, and the answer would be 20. So just keep in mind, again, that the radius is if you start on the outside of if you start at a point on the circle and you go halfway through to the center, you would say, hey, that's the radius. If you go the full way across, that's the diameter. All right, and the diameter is twice the radius, and the radius is half of the diameter. So the two formulas that you'll want to use for circle calculations are the area equals pi r squared, and also the circumference. So for the circumference, you have a couple different options. You can either do 2 pi r, or you could just do pi times d. Okay, and so one more thing to note here is that this pi symbol, it's just a number that's approximately 3.14. So if you ever have to use pi in a calculation, just put in the number 3.14. Now, a lot of test takers stress out over, oh, do I just leave the pi symbol in the answer choice or do I do 3.14? And the answer is it depends. It could be either way on the test. If anyone's taken the GD Math section already and has experience with this, please let us know down below in the comments if you want to. What your experience was like on the test. Did they leave pi in the answer choices, or did they make you actually use 3.14 in the calculation? From the practice test examples that I've looked at, I've seen it both ways. But in this case right here, this question says, what is the area of a circle that has a diameter of 20 inches? And in each answer choice, we just see that they left pi as the symbol right here. So if you see this in the answer choices, then you don't have to do 3.14 in the calculation. So that's one way to tell is just look at the answer choices. If you see pi, then you don't have to use it in the calculation. You can just kind of let it hang out there. So let me give you a chance now to pause the video, try this question out, and whenever you're ready, we'll go over the answer. Okay, so this is kind of just like a plug and chug type of question where you just take numbers and plug them into the formula, but there's one little twist here. So the formula that is on the formula sheet for the area of a circle, it's pi r squared. But the twist here is that this question gives us the diameter of the circle. It doesn't give us the radius. So we know, though, that to get the radius, we take that diameter and we cut it in half. So if the diameter equals 20, we know that the radius must equal 10 because the radius is half of the diameter. So you take the diameter of 20, you cut it in half, and that gives us 10. So the radius here is 10. So when we actually go to do the calculation, what we'll do is we'll do area equals pi times 10 squared, or 10 times 10. So pi times 10 times 10, because 10 times 10 is the same as 10 squared. And the answer here is 100 pi, right? Because 10 times 10 is 100. And usually you write the pi symbol after the number. So the answer here, when all said and done, is 100 pi. So A is the correct answer here. So here's another take on the area of a circle questions. So this area of a circle variation gives you the area. It says the area of the circle is 64 pi. What is its diameter? So now we have to find that diameter given the area. So let me give you a chance now to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. So one thing I just want to point out here is that, again, the formula for the area of a circle, it's pi r squared. And this question is asking us what is the diameter. So at the end, before we're done, we just want to double check that we found the diameter instead of the radius. But the way we want to set up this question is we're going to take the area of 64 pi and we're going to take the 64 pi, plug it in the formula up here for area. So that's all I'm doing here. So 64 pi equals pi r squared. And we're going to solve for the radius, and then we're going to convert it to the diameter. So we've got a pi on both sides of our equal sign, so fortunately they're going to cancel out, leaving us with 64 equals r squared. Now, the way a lot of people would try to do this to get r is they would try to square both sides. They would say, well, I have 64 r squared, so I have to do 64 squared, and that's going to get me r. And that's a really common mistake that I've seen test takers make many times over the years. But really what we want to do is take the square root of both sides. So what is the square root of 64? The square root of 64 is 8. What is the square root of r squared? The square root of r squared is just r. So we've got 8 equals r. So A is the correct answer and we're done. Actually, no, we're not done because we've solved for the radius, but the question is asking for the diameter. So we have to go one step further here. So if you have the radius and you need to get the diameter, you have to double the radius. So what is 8 times 2? 8 times 2 is 16. So 16 is the correct answer here. And if you forget how to go from radius to diameter or vice versa, just remember those pictures, right? So here is my, I don't know what this is. It looks more like an apple than a circle, but just pretend this is a circle. So the radius would be going halfway across the circle. The diameter goes the whole way across that circle. Just kind of remember that picture and just remember that, hey, if I've found that 8 is the radius, well, that's only half of that circle. So I have to double that to get my answer here. So C16 is the correct answer here. What is the circumference of a circle that has a radius of 20 inches? Is the answer A, B, C, or D? So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so before we jump in and talk about the calculation, there's one thing that I could note here right off the bat. If you look at the answer choices here, we don't see the pi symbol in any of them, so that tells me that I'm going to want to actually use 3.14 in the calculation. The other thing that I note here is that it says, what is the circumference of a circle that has a radius of 20 inches? So I'm going to pick the formula that has the r in it for radius. So this is kind of just a plug and chug type of question. We just do c equals 2 pi r, and so I'm going to do 2 times 3.14. And I'm just going to write the 3.14 out instead of using the pi symbol here. And then I'm going to write 20 for the radius. So to set this up, I have 2 times 3.14 times 20. And if we do this in our calculator, we'll see that C is the correct answer here, 125.6. So now let's talk about right triangles. So how do you know if a triangle is a right triangle? Well, a dead giveaway is when you see a little box like this down in the corner. If you see a little box like this down in the corner, that tells you that this is a right triangle. So side A and side B, they are perpendicular and they form a 90-degree angle, right? So if I just trace line A and if I just trace line B, you can see here, hopefully, that they cross and they form this 90-degree angle. So the most important point of this part of the video is whenever you see a right triangle on the test, that's a sign that you're probably going to have to use this formula, a squared plus b squared equals c squared. So you'll want to go to the formula sheet and find this formula. You don't have to memorize it. One last thing to know before we jump into some problem solving examples is that the biggest side of the triangle is always going to be side C. So side C is called the hypotenuse. It's the biggest side of the triangle, and it's the side that's directly across from the 90-degree angle. Let's go over an example of a Pythagorean theorem question. And on the screen here, we see that for this triangle, we know that the length of this side is 8 and the length of this side is 6, but we don't know the length of side C. And please disregard any units for this example here. And the question is, what is the length of side C of the triangle above? So let me give you a chance now if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so let's talk about this question here. So if I look over here at the formula, I see that it's a squared plus b squared equals c squared. So what I see here is that side A corresponds with 8, right? So for A, I'm going to use 8. So I'm going to write 8 squared. And I see here that side B corresponds to 6. So I'm going to write 8 squared plus 6 squared. Now, I don't know what C is, so I'm just going to leave that as C squared. So far we have, let me pull this up a little bit, make a little more room here. We've got 8 squared plus 6 squared equals C squared. So now let's take this a step further. Let's do some math here. And so we know that 8 squared is 64. And we know that 6 squared is 36. And you're more than welcome to use your calculator if you need to, as much as you want to throughout this video. And so we've got 64 plus 36 equals C squared. Now 64 plus 36 is 100. So we'll have 100 equals C squared. So this is the part where a lot of test takers, they'll do a really good job and get to this part, but then they'll think that they have the answer. They'll think, well, the answer must be 100. So if you did this, absolutely no worries, don't feel bad. But right now we see that 100 equals C squared, and we don't want to find the length C squared, we just want to find C. So we've got to go one step further here, and the way that we solve this is that we want to take the square root. So a super common mistake would be to think that to get C, we have to do 100 squared. But what we really want to do is we want to take the square root. So if you made that mistake, absolutely no worries. We're just practicing right now. Don't feel bad if you did. But just a heads up on the test, if you get a scenario like this, that what you'll really want to do is take the square root. So the square root of 100 is 10. So when all is said and done, we see that 10 is the answer here. Now let's look at a different example. And in this case, we don't know the length of side A. So here we want to figure out the length of side A. So it says, what is the length of side A of the triangle shown above? So if you'd like to, let me give you a chance to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so in this case here, we can see that the 17 on the triangle corresponds to side C. So up here where it says C, I'm going to put in 17, and we can see that 15 corresponds to side B. So I'm going to come up here into the formula, and I'm going to plug 15 in for B. So we don't know what A is, so I'm just going to leave it as A squared. So I'm going to write A squared plus 15 squared equals 17 squared. Okay, so now let me just do some math here and simplify this. So I'm going to write A squared plus 15 squared. And what is 15 squared? 15 squared is 225. So I'm going to put 225 right here. And what is 17 squared? 17 squared is 289. So I'm going to write 289. So I now have A squared plus 225 equals 289. Now the name of the game is to figure out what A equals. I have a plus in front of this 225. So what I want to do is subtract 225 from both sides. So if I subtract 225 from both sides, I'm going to see that A squared equals 64, right? And the reason that is because the 225s are going to cancel out here. And then when I do 289 minus 225, I get 64. So I have A squared equals 64. So now how do I get A? Do I do this? Do I do 64 squared? Or do I take the square root of 64? Well, the right way to do this is to take the square root of 64. So we want to take the square root of both sides here, and we'll see the square root of A squared is just A. The square root of 64 is 8. So when all is said and done, the correct answer here is 8. So now let's talk about some basic key triangle properties. So when I look at this triangle right here, the first thing that you should know about this triangle is that we could name this triangle in a couple different ways. So when it comes to naming this triangle, I could call it A, B, C, right? So I could just kind of start at A and I could just go around A, B, C, and I could name it like that. Now, I could also name it C, B, A, and that would be another valid way of naming this triangle. I could write C, B, A. Now, I could also go the other way, and I could start at C, and I could go C, A, B. So the point I'm trying to make here is that when you name the triangle, all right, when you name triangles, you can name the vertices in any order. Now, you might be wondering, vertices, what does that word mean? Well, basically, vertices are the points where two lines come together. So here's an example right here. All right, so we see that this line and this line come together. So that's just what I'm talking about when we say the vertices. They're just the parts of the triangle where the two lines come together. So here's another example. So this line and this line are going to come together right here. All right, but the main point, again, when it comes to naming is that we can list these vertices in any order. You could say A, B, C. I could also say C, B, A. I could say C, A, B. Those are all valid ways to name the triangle. Now, we could also, when it comes to naming sides, so take, for example, this side right here of the triangle. So we could call this side, we could say side AB, or we could call it side BA. All right, same with all the sides. So this side over here, we could refer to this as side BC. We could also call it side CB. Another key point to understand about triangles is that the internal angles of a triangle must always add up to 180 degrees. So if we look here at our triangle on the screen, we'll see that there are 3 different internal angles. Now this triangle here, it's a closed shape, right? It's not open. and it has internal angles. So it has 1, 2, 3 different internal angles. And the point here is that these internal angles are always going to add up to 180 degrees. So we can say that angle A plus angle B plus angle C equals 180. So we're going to now look at some examples of classifying triangles by their length. And one example is the equilateral triangle. So the equilateral triangle, I have an example of one shown on the screen here. And there's really only two things to note about the equilateral triangle. So first is that all of the sides in an equilateral triangle are the same length. So the word equal here, hopefully that helps you remember that an equilateral triangle has sides that are equal in length. So again, for an equilateral triangle, all sides are the same length. And also we note that all of the angles are 60 degrees. So this is an equilateral triangle, all sides are the same length, all angles are 60 degrees. So hopefully equilateral triangles are pretty straightforward. So what you're seeing on the screen here are two bicycles, but the point here is that a bicycle has two wheels. And the word bicycle kinda sorta not really rhymes with iso. Bicycle, iso. Maybe that's kind of a dumb way of remembering it, but the point here is that an iso or isosceles triangle has two sides of equal length. So on the screen we see a picture of an isosceles triangle, and we see that this side is equal in length with this side. That's what the two little bars here tell us, that these sides are equal in length. Now, if we look at this side here, and we consider the angle that's opposite to this side, and if we look at this other side right here, and we look at the angle that's opposite to that, what we need to know is that both of these angles are going to be equal in measure. The second point about isosceles triangles to know is that the angles opposite from the equal sides are equal in measure. So again, these two angles right here are equal in measure for the isosceles triangle. So now we come to scalene triangles. And the main thing to know about scalene triangles is that nothing's equal. So scalene triangle, nothing's equal. None of the sides are equal and none of the angles are equal. So for a scalene triangle, no sides are equal and no angles are equal. So one trick to help you remember this is to first put the three triangles in alphabetical order. So they would be equilateral, isosceles, scalene if we put them in alphabetical order. And then all you have to do is remember this: 3, 2, none. Right? Because an equilateral triangle has 3 equal sides and 3 equal angles. The isosceles triangle has 2 equal sides and 2 equal angles, and the scalene has none. None of the sides and none of the angles are equal for scalene. So that's just a little memory trick. I think I learned that from mathisfun.com many years ago. So right now on the screen, I'm showing you a cute little puppy, and I promise there's a point to this. Okay, let's talk about the point. So the point here is that we can also classify triangles by angle. And one example of this is an acute triangle. And with an acute triangle, all of the angles measure less than 90 degrees. So one way to remember this is you think about that cute little puppy. And if you see a cute little puppy, you say, wow, a cute little puppy. Well, a cute little angle, a cute little puppy, a cute little angle, all angles measure less than 90 degrees. I don't know, that's a pretty stupid way to remember it, but hey, if that helps you remember it, great. If that just wasted your time, sorry about that. So the next type of triangle that we can classify by angle is the obtuse triangle. So an obtuse triangle has one angle that is greater than 90 degrees and then two acute angles. So in this example here, we see one angle of the triangle that's more than 90 degrees, and then the two other angles would be less than 90 degrees. So again, an obtuse triangle has one angle that's greater than 90 degrees and then two acute angles. And acute angles are angles that are less than 90 degrees. When it comes to classifying triangles by angle, the last example that we're going to look at is the right triangle. And we've already talked a little bit about right triangles earlier in the video, but a right triangle, again, is a triangle that has a 90-degree angle. And if you ever see a triangle that has a box like this, a little box type thing down in the corner, that tells you that it's a right triangle. And in many cases, in order to solve a question correctly that involves right triangles, you're going to want to use the Pythagorean theorem, this formula a squared plus b squared equals c squared, and we looked at some examples of that earlier in the video. So here's an important example when it comes to triangles. The triangle below has 3 internal angles. How many degrees does the missing angle measure? We see here we've got one angle that's 40 degrees, one that's 60 degrees, and one that is unknown. And it says, please write your answer in the box below, but obviously you're not going to be able to really write your answer through the screen. So maybe write it down on a sheet of paper or however you want to do it. It doesn't really matter, but let me give you a chance now to pause the video and try this question out. And whenever you're ready, just unpause the video. And if you get stuck, don't worry, because we're just going to talk about how to do it. Okay, so the key to getting this question right is remembering that the internal angles of a triangle have to add up to 180 degrees. So we can set up an equation here. So the two angles that we know are 40 and 60 degrees. So we can say 40 plus 60 plus x equals 180. Now, if you're wondering, why did I put an x here? Well, I put an x here to represent the unknown angle. Now, you could have used A, you could have used B, you could have used Z, you could have really put anything in here, you could have used Y. I just chose X, but I have the equation set up as 40 plus 60 plus X equals 180. And remember, the three internal angles of a triangle have to add up to 180 degrees. Okay, so 40 plus 60 equals 100. So I can rewrite this as 100 plus x equals 180. And when you're doing your math, you don't necessarily have to write out every single step like this unless you want to. I'm just doing this more for instructional purposes. So I'm going to now subtract 100. So if I do 180 minus 100, that gives me 80. So x equals 80. So the missing angle is 80 degrees. So this question says the triangle above has two sides that are equal in length. One angle measures 70 degrees, while the measures of the other two angles are unknown. What are the measures of the missing angles? So now's your chance, if you'd like to pause the video, try to figure this out, and whenever you're ready, we'll go over the answer. Okay, so in this case here, the key to getting this right is to see that these two sides are the same lengths and to understand what that means. Well, if these two sides are the same lengths, that tells us that we have an equilateral triangle. And for an equilateral triangle, these two angles are going to be equal in measure. So what we can do is set up an equation, and we can do 70 for the angle that we know. We can do 70 plus x equals 180. Now, why did I do x plus x here? Well, because we don't know what either of these angles measure out to, but we know that these angles are both the same. So I can call them both x because they're going to be exactly the same. So we have 70 plus x equals 180. So I can now write 70 plus 2x equals 180. So now what I'm going to do is subtract the 70. So I subtract 70 from both sides. It cancels out on the left side, and whatever I do to one side, I also do to the other. So I do 180 minus 70. So I have 2x equals 110. So now how do I get x? Well, I'm just going to divide by 2 on both sides here. So if I divide by 2 on both sides, what I'll see, and it is 55. So now we're going to talk about four-sided plane figures. And earlier we talked about squares, and the context then was how to calculate the area and perimeter of squares. Now the context is four-sided plane figures, and the square is the first example of a four-sided plane figure that I want to cover here in this video. Now you should note that a square is a kind of rectangle, and on your test, I doubt they're just going to ask you like a trivia question like true or false, is a square a kind of rectangle? I don't think you're going to get a question on that, but if you have a textbook, whatever company it is, or if you're taking a prep class or something like that, I'm pretty sure they're going to tell you that a square is a kind of rectangle. So I just want to throw that out there for you, just so we cover all our bases. But as far as problem solving goes, that's not the most important thing to remember, in my opinion. Point 2 here is that all four sides of a square are the same length. So if we look at the square here, all four sides measure out to be the same exact length. For all four-sided plane figures, including squares, the interior angles add up to be 360 degrees. And when we look at the square right here, all right, we can see that it has four 90-degree angles. And so if we add them up, if we do 90 plus 90 plus 90 plus 90, we're going to get 360 degrees. So now we're on to rectangles, and there really are only a couple points here to note about rectangles in the context of four-sided plane figures. The first is that the sides across from each other are equal in length and parallel. So When it comes to squares, we know that all four sides are equal. With a rectangle, we have two sides that are equal, right here, and two other sides that are equal. So the sides that have two slashes are equal to each other, and the sides that have one slash are equal to each other. So hopefully that makes sense. And we also should note about rectangles that they have four 90-degree angles, right? One in each corner. So similar to a square, there's going to be four 90-degree angles that we find within the rectangle here. And for all four-sided plane figures, including squares, including rectangles, the interior angles add up to 360 degrees. So now let's talk about parallelograms. So what you should know about parallelograms, besides the fact that it's kind of a tongue twister to say, the opposite sides are equal in length and parallel. So let me highlight which sides are equal. So this side that I'm giving one slash is equal to this side that has one slash, and this side is equal to this side. So again, the sides that have two slashes are equal in length, and the sides that have one slash are equal in length. So that's one point to note about the parallelogram. And when it comes to problem solving, number 2 is really, really important. It's important to note that opposite angles are equal. So let me take this angle right here, this internal angle, and let me just call this angle A. And let's say that angle A is equal to 150 degrees. And I'm just making this up just to give us an example, but let's say that this angle is 150 degrees. And then let's say that I say, well, this angle down here, this is angle B. What if I told you, what if I asked you and I said, what is the measure of angle B? How would you figure that out? Well, we can just look up here and say, well, since this angle is 150 degrees, since A is 150 degrees, B also has to be 150 degrees because these angles are opposite from each other. So again, the angles that are opposite are equal. So the opposite angles are equal, right? So likewise, this angle right here, let me call this angle C. Angle C is opposite to this angle right here, which let's just call it angle D. So what we can say is that this angle here, angle C, is equal to angle D. And so the third point here is that for all four-sided plane figures, the internal angles add up to be 360 degrees. I'm sure you've heard me say that before, but I just want to keep repeating that for each four-sided plane figure we look at because it's important to remember. So now let's talk briefly about the rhombus. And there's not a whole lot to know about the rhombus, but I'm just kind of showing you this just to cover all our bases here. But the most important thing to know is that a rhombus is a special parallelogram. And a rhombus has four sides that are equal in length. So if you forget which one is the rhombus, it looks like a diamond, basically. So a rhombus looks like a diamond, and the interior angles of all four-sided plane figures add up to be 360 degrees. So now on the screen, what we see is a trapezoid, and there's a couple points to know about the trapezoid. The first is that a trapezoid has one pair of parallel sides. The second thing is that we don't know the measure of the angles or side lengths from the definition. And you might be thinking, well, what in the world does that really mean? So remember how for the parallelogram, we could look at the angles, and if you knew one internal angle, you could look at the opposite angle, and then you would know that angle as well. We're not going to be able to do that with the trapezoid. So that's just an example of what I mean by number 2. And the third point here, again, is that for all four-sided plane figures, the interior angles add up to 360 degrees. So here's a practice question to help test your understanding of some of the key concepts behind four-sided plane figures. And don't worry about answer choice E, I just took that out, so you're just choosing between A, B, C, and D. So let me give you a chance to pause the video and try this out, and I'd like you to not just pick out which one you think is correct, but also think about why are the other choices that you didn't pick wrong. And if you get stuck or you're not sure, don't worry because I'm just going to tell you what we need to know about this question after you unpause the video. So let me give you a chance to try it now. Okay, which of the following is true for all four-sided plane figures? Is it A? Let's think about it. The sum of the interior angles is always 180 degrees. Well, this is true of triangles, but it's not true of four-sided plane figures. So I'm going to take A out. B, they have four right angles. This is true for squares and rectangles, but it's not true for all four-sided plane figures, so I'm going to take B out as well. Now what about D? All four sides are equal in length. Well, that's true for squares, but that's not true for all four-sided plane figures, so I'm going to take D out. And that leaves us with C. The sum of the interior angles is always 360 degrees. This is true for all four-sided plane figures. So hopefully you understand that C is the right answer here, but you also see why A, B, and D are incorrect.